In this episode of Finogrid Machining, we are making a part that actually rotates. This is the raw material for that one, and it will be, this was the tube, and it will be placed around here, about, of course, above this thing. And there will be a shaft going through this one, yeah, okay. So this thing is, there is one really critical dimension in this part, and this will be the shaft hole. I will use some special methods to do an accurate hole which is totally straight and which is also good dimension for shrink fitting one more time. So it will be a 25mm hole, a little bit under, yeah, okay. But first we will make the side that is not so critical, which is going actually over here. It will be going over here so that it will prevent dust from entering the bearing. There will be a bearing surface inside there, and that's something that we need to take very good care of. It has to be perpendicular with the hole inside here, and yeah, well, that's let's see how that goes. So let's work once again. Okay, so here's now the piece of material I'm going to use for this thing, and the first thing is to chuck it. And well, this is again our chuck which has self-centering jaws, and this will be somewhat difficult to make it so that it is straight in there. So let's try if I can get it straight, really. Sometimes this chuck is, has surprised me. First of all, check that the jaws are clean. That's, they are. I'm wiggling it, just hopefully. I didn't tighten it properly. The next step will be dialing. Okay, let's put the 0 somewhere there. Okay, let's see what we are at. Wow! Well, at the moment it's 0.3mm total deviation. Okay, that's probably near. Okay, now we are 0.1mm deviation here. Let's tighten the jaws a little bit. That's low. How much is it? Okay, low. It might well be that now it's 0.05 of a millimeter. I believe I cannot get it any better than this, and probably this is also out of round. Now when I move it around here, let's see if we have same deviation. Yeah, it doesn't change. So it's sitting straight actually, which is good. So now let's see if it changes when I tighten it. Didn't change much, at least. Actually it became better. It's 0.03 of a millimeter at the moment. And next step is to face it with this tool. You probably have noticed that I always take this tool away from here. That's just a safety precaution. I don't want it to dangle here and be on the way when I do something. So let's see now. almost totally cleaned, so this is the cleanup pass. Okay. Intention here is just to clean up the the scale away from this workpiece. I am taking about half a millimeter away from this, and the outer dimension is not critical at all. So let's go. And it will be 1000 revolutions per minute. And I said half a millimeter cut. This is for the something quite large diameter. And then we have the feed is 1C. It's 0.300 of a millimeter feed per revolution. So let's go. I will drill a hole through this piece of material. It will be first center drilling, and after that I will drill a hole. This is I just took one drill there, 12.5 millimeters. This didn't grip. Now it did grip. Okay, did it? Yeah. So so what is the speed here? Not that much. 800 looks like a good. Oh, yeah. This is not too fast. So let's see how it starts. And it started all right. The next step is to drill a recess here for this guy, and it should be sitting about half the way through, and I measured it and there is a bearing also, so it's about this much. So this is now touching the surface here, and we have this stop here, the rigid hard stop, so I can actually, what I can do, I will put this like that, and now we have exactly 25, this is 25 millimeters. We have 25 millimeters movement there. So I lock the answer here. Let's see that it really is now that, yeah, it feels like that. So put this in place. And now the depth is there, and the diameter will be here over this, and our diameter is actually 42 millimeters. Then it's loose enough. So, and this is by no means an accurate dimension. It's just a recess so that it can go inside there. And what we are using here now is a hard stop, and we'll stop there like that. Well, this will be fun to do. It will generate some chips. Maybe my last experience from this was that it will generate something like that the suitable chips come out with 0.3 millimeter steps. So 1000 RPM. Then I will touch. Let's see about the movements. That's okay. That's not feeding okay. Why? So it's very slow. That's why. We could use, I think, that one. And it's wrong direction because I want to feed it out from the hole. Okay, let's see. Now I will touch this. There you are. Then I go to the stop here, and then I take first 0.3 millimeters. 1, 2, 3. Let's see how this goes. It makes bird's nests. And this is really bad. after 1 hour at least boring this, we are at 41 millimeter, and our goal is 42. So what I will do now is to take first an ordinary 0.5 millimeter cut, which I have been doing here quite many, like this, and then 0.5 millimeter, like that, and then we start feeding out and hope that there doesn't become a big bird's nest. And yes, this dimension is not critical. It must just be big enough. Yeah, so it's forming bird's nests, as you can see. Yeah. And now we are starting to do the final cuts. This finish is really bad. So what I will do now is to we have 0.5 millimeter to go here. So I will take now 0.25 millimeters. It will be a little bit smaller bird's nest. Well, yeah, this is yeah. Okay. That was now we have 0.25 millimeters to go, and the surface finish isn't still very good. So now we are going to slow down the feed to half what it was, and then we take half of the rest, which is about this is about, I believe, 1/10 of a millimeter for our finished pass. Now it will be really slow, and this one should produce a very good surface finish. Actually, let's see how it looks like. I will zoom you now in. Well, it's still a little bit lumpy, but oh yeah, it's quite good. Okay, let's see, just for the fun of it, where we are at. This should now be 41.9, quite exactly. Oh, no oil in there, so it's quite exactly, actually. So now we have 1/10 of a millimeter to go, and this one now, what I will do now is to there is this backside face which is which should be, and it is actually quite flat, but I will make it even flatter. So we go in like that, and then I feed in with the compound just a little bit. Okay, I need to go somewhere there and then feed with the compound. it's okay. So let's suck. Do we have? Oh yeah. I turned this piece in the chuck, and now I have taken this down about 6 millimeters. Very rough cuts, and well, the reason why I did that is that next thing I want to do is to part it off from there. No, not with this tool. This is wrong tool. This should do the trick. So now it reaches all the way through. It didn't reach when it was there. Let's see if I can put it. Okay. I can adjust that one with the compound actually. Yeah. I will lock the carriage. Yeah, should be there. Let's see. It's good. And now, well, this is now something. This, of course, needs to be tight. And is it still? But this is probably too fast. I will take it down a little bit. That's probably the correct speed. So let's part it off. Maybe I should use some cutting oil in there. You can cut dry, but this is probably the correct way to do it. Cuts better. Yeah. It is way better. Well, now, let's face it. Just my eye protection and, well, let's lock the carriage there. Again, feeding with compound. Okay, that's good. Let's go. Okay, now the hole is at the moment 24.14 millimeters, and our goal was 24.94. So I will now take a very I will take 0.2 millimeter cuts from this one, and I'm using cutting oil for the surface finish. Okay, 0.2 millimeters, 0.1, 0.2. Just sucked the chips from the hole. The surface finish is actually, well, it's quite good. Yeah, it could be better, but this one is good for us. So now it should be 24.34. Let's see if it is. It should be. And it is. It really is. We are on the track. So 34. Okay. Next. $34, $44, $54. So 54, 64, 74. So 74, 84, and 94, right there. Okay, then we go. Wow. Oh yeah. I think we are exactly there. Okay, we finished this one. Well, it's not finished, but it's still it's as far done as we can do it at the moment without the shaft. So it looks pretty good actually, And the hole there, which is then shrink fit with the shaft, is now quite exactly 24.94 millimeters. So when I heat this up to 200 degrees, it will drop in there. It will. If in that case it doesn't drop, it will actually destroy both the shaft and this one. So yeah, actually I will warm it so that it becomes a little bit bluish, so then I'm pretty sure it will drop in there. It's around 300 degrees then. So yeah. And why didn't I do the whole shaft from a single piece? It's the recess here. The shaft is coming out here, and it's no way you could easily do this kind of thing in a lathe. Yes, trepanning, yes, but I'm not that advanced. So, in the next episode we will be doing the shaft itself. It will be hard turning, because it's a case-hardened shaft, and we are going to use some CBN insert for this operation. It will be really fun. Till then, see you!